Hi everyone, this video is connected to section 4.4, logarithmic properties. So we're going to go ahead and solve this logarithmic equation that reads the natural log of x plus the natural log of x minus 6 is equal to the natural log of 6x. So given the fact that you have a bunch of natural logs in here, we are probably going to want to use our logarithmic properties to help us out. And also given the fact that you have an equal sign contained in here, making it an equation, it means that our goal here is going to be to solve for x. So one of the first things that I do notice is I do have this plus sign that's located on the left-hand side. And ideally what we would like to do is we want to try to consolidate the left-hand side here. So it makes me think of our addition property for logarithms, which reads as the log base b of m plus the log base b of n is equal to the log base b of m times n. So that means I can go ahead and rewrite this left-hand side so that it's the natural log of x times the quantity x minus 6 is equal to the natural log of 6x. So the right-hand side remains unchanged at this point. So what I want you to notice now is that on the left-hand side, notice that I consolidated everything so that there is just one natural log. And on the right-hand side, there already was just one natural log. So the reason why I want you to pay attention to this is because in this situation, when you just have a single log on the left-hand side and a single log on the right-hand side, you can kind of just use the shortcut that allows you to rewrite so that the natural logs are no longer there, and that you can just use straight algebra. So some of you might be kind of furrowing your brow and kind of going, well, why are you allowed to do that? Can you just say that and go on with your day? The answer to that is yes, but of course we should actually investigate as to why that is. So I'm going to move this over for a little bit, and I'm going to spend some time with it. So I'm just going to rewrite that line of the natural log of x times x minus 6 is equal to the natural log of 6x. And here is the full explanation as to why we can basically get rid of those natural logs. If you recall, we do have a property, an identity property, that says that if you have an exponent with a base of b, and there is a log also with a base of b located in its exponent, the result will be just the number that is having the log that's being logged. So what happens in this case is that since you have a exponent with a base of b and a logarithm with the base of b, since they're inverses, they will take each other out, but that's only when their bases match. Okay, so essentially what I'm going to do is I'm just going to rewrite this line that you see here. So the natural log is the same thing as a log with a base of e. Okay, and what I want you to note here is that I haven't done anything to change or manipulate the problem. I've just rewritten it. So at this stage, what I'm going to do, and this may sound strange, but basically I'm going to treat each of these sides that you're seeing here as exponents. And I'm going to deliberately choose an exponent with a base of b. So as I finish writing out this line, think about why that might be. Why did I choose e? And hopefully what you're saying is, well, if you have a exponent with a base of e and a log within that exponential position with a base of e as well, that's going to allow me to use that property, or that identity property, to cancel them out, which would then leave me with x times the quantity of x minus 6 is equal to 6x. If you notice, that is what we had said originally. Okay, so on the left-hand side, you see just the shortcut. On the right-hand side, you see a fuller explanation. And some of you might be saying, well, is that legal? And I can honestly tell you, yes, it is legal. The reason why I picked e was because it matched the base of the logarithm that I started off with, that natural log. You technically could have used 2's in this position, but it would have just made the problem worse, and it wouldn't have allowed you to use that property to cancel anything out. So that's why I was deliberate and picked an exponent with a base of e. Alright, so let's go ahead and continue. I'm just going to rewrite where we left off and kind of have a clean space again. Okay, so I'm going to go ahead and solve this, and we're going to have to do a little bit of back and forth here, so bear with me. One thing that I would suggest doing is I would distribute. So we have x squared minus 6x is equal to 6x. And notice here I have a quadratic, basically because the highest degree that I'm seeing here is a 2, or a squared. I'm going to try to combine like terms here and see what happens. So I have x squared minus 12x is equal to 0. From here, it may seem counterintuitive, but I am going to go ahead and factor that x out again. So I have x times the quantity x minus 12. I did that because now I can use, well, my logic here that states, well, if I have x times the quantity x minus 12 and it equals 0, x could be equal to 0, or this quantity x minus 12 could be equal to 0. Here is one of my potential answers, and if I solve, here is the other of my potential answers. And what I want you to note here is we're going to investigate this a little bit more in the next lesson, but we should check to make sure that our answers do work. So, because in some cases we're going to get extraneous solutions here. In other words, they appear to be solutions given the fact that we've been manipulating everything around, but in reality, if we went back to check, we would have an issue. So here's what I mean. So I'm going to start working with this as my first check. So if I do the natural log of 0 plus the natural log of 0 plus 6 is equal to the natural log of 6 times 0. This would end up cleaning up. Oops, sorry, that should not be a plus in there. That should be a minus. Natural log of negative 6 is equal to the natural log of 0. If you were to go to your calculators, you would end up getting an error message here, because you are not able to take the natural log of 0. And that really has to do with the domain and range for logarithms, which we are going to investigate in section 4.5. So what I am saying here is that x equals 0 is actually not an option. This one is an extraneous solution. It appears to be a solution, but actually when you go and check it, it's not gonna fly. So we'll go ahead and we'll check with the 12. So natural log of 12 plus the natural log of 12 minus 6 is equal to the natural log of 6 times 12. This becomes the natural log of 12 plus the natural log of 6 is equal to the natural log of 72. And if you recall, you can actually go through and use your calculator, but we can also use our properties again because, again, we have that plus sign that's happening in there. So this is going to give me the natural log of 12 times 6 on the left-hand side, and lo and behold, we would get a true statement. So this one does check out. Okay, so I hope that that helped. If you do have any questions, please let me know, and that's it.